Welcome to Ask and Learn.
To use the ideal gas equation, PV is equal to nRT. You can rearrange that for any of the PV and RT in the equation. So the first thing we're looking to calculate is the volumetric flow rate of air drawn into the furnace. And that is 1.66 times 10 to the 6 meters cubed per hour. Following on from this, then what we can have the molar flow rate of the gases. So the second molar flow rate we can calculate is 137782.17 kilomole per hour. Moving on, we have the volumetric flow rate of gas leaving the furnace now. That is 6813.239 meters cubed per hour. And then we can calculate the feed rate of limestone. So that is 43.575 kilograms CaCO3 per hour. And we have the molar flow rate of gases again to calculate, 137716.77 kilomoles per hour. Next we have another volumetric flow rate to calculate following this, that's 2426.881 meters cubed per hour. We have the gas velocity at the point in the stack is as follows, 53.24 meters per hour. Next, we can calculate the concentration of sulfur dioxide, that is 316,410 parts per billion.